Doom was distributed using a shareware model similar to previous id Software games. And this version included the first episode with 9 levels called Knee Deep in the Dead. And when you try to start the other 2 episodes, an advertising screen appears with an offer to buy a full version of the game. And besides, the shareware version fit on only 2 floppy disks, which contributed to its rapid spread among gamers. So, after installing the game from these disks, apart from text files and drivers, 2 main files are directly related to the game itself. The first Doom X file was the game engine itself, and all the assets of the game were in the Doom WAD file, the extension of which just means, where is all the data? So for our work we need only a WAD file. For the shareware version it is called Doom 1 and for the paid version it is just Doom. And since the first version is for free distribution, I will use it, but you can use any of these too. And when you have decided on the version of the WAD file, then place it in the project folder, let's say in a directory called WAD. So, as I mentioned in the introduction, we will be recreating the Doom engine in Python using the Pygame graphics library, which is essentially a wrapper for the C language SDL library. And I would like to say a few words about the version of Python used. This is version 3.10, this version is used because at the last moment for texturing, I decided to use a 3D array as a frame buffer, and in order for the iteration speed over such an array to be at the level of compiled languages, I used just-in-time compilation of some functions using the Numba module. This allowed me to achieve higher performance and get rid of some of the shortcomings that arose when applying textures using the standard Pygame tools. And since at the time of the creation of this video, Numba supports a version of Python no higher than 3.10, therefore, the choice was made in favor of this version. And getting back to the WAD file, according to the Doom wiki, this file always starts with a header, so let's get the project ready to read the data from the WAD file. So, in the main file, we will create the Doom engine class. At the input of the constructor of which the path to the WAD file is specified, we will take the path into an attribute, and create an instance of this class. Now, to read the data, we will create a WAD reader file. There will be a class of the same name, where we will open our file for reading in binary mode, and we need to create a method to close it. And to store and transform data, we will create a WAD data class that will have access to an instance of our engine and in which we will create an instance of the WAD reader class, and with the help of which we will read the necessary data. Then we import the WAD data class in the main file, and create an instance of it in the onInit method. Such a class structure will be quite convenient for getting data, and now we can move on to reading the header. So, to get the header, we need to read 12 bytes, the first 4 bytes are ASCII characters indicating the type of WAD file, and then there are 2 signed integers of 4 bytes each, necessary to get the file directory with which we will get access to all file assets. And for this we will use the struct module. With the help of it we can convert the read bytes corresponding to the data types of the C language into the data types necessary for Python. Then we will write the main method for reading bytes for which we specify the offset in the file, the number of bytes to read in their format for using the unpack method of the struct module. And now, using this method, we can write a method for reading strings from a WAD file. For this we take into account how to decode bytes and use the notation for the char data type according to the struct module. And let's create a method for reading 4 bytes, specifying the data format. It can be used to read both signed and unsigned 32-bit integers. And so, we can now read the header of the WAD file. Let it be a dictionary with keys for the type of file, the number of so-called lumps, the lumps are the assets of the WAD file, and the initial offset where these lumps begin. And let's call this method to get the header, and then print its data. If we run the program, we can finally see the first data that we got from the WAD file. And we need this information to read the directory with which we will get access to all the lump assets of the file. So, to read the directory, we need to read 16 bytes for each lump. This will be a list in which we will place a dictionary for the next lump, the keys for which will be its offset in the file, size and name. We read the name 8 bytes long since it was the maximum size for a file name in MS-DOS times. Let's use this method to get this directory, and look at its contents. So we see that we now have a list of all lumps with their names, offsets and sizes. But to make sure that we got this data correctly, I suggest installing the Doom editor SLADE 3. And if you open your WAD file in this editor, you will see a list of names. These are the very lumps that are in our directory. And in our case, I recommend using this editor specifically to check the correctness of the data received from the WAD file. So E1M1 is the name of the first Doom map, followed by 10 lumps that contain specific data for building and rendering this map. Subsequently, we will consider all this data and figure out what they are for, and let's start with getting the vertex data. Obviously vertex is the 2D x and y coordinates on the map, and in the WAD file these coordinates are two 16-bit signed integers. Then we need to write a method to read 2 bytes as 16-bit numbers, and along with this method, we will also need a method to read 8-bit numbers later on. So, now we can write a method to read a single vertex at a given offset, and for convenience, we can use the 2D vector class from the Pygame math submodule for the vertex coordinates. But now we need to specify that we will receive the vertices for the first Doom map, and all the main data for the engine will be contained in the WAD data class. Let's write a method by which we can find the index of a lump in our directory, and this method will come in handy more than once. And then we use it to find the index for our map. If we run the program, we will see that the index of the E1M1 map is 6. We can also verify that this index is correct using the data from the SLADE editor. And we also need a dictionary, the keys in which will be the names of the lumps that go directly after the name of the map, and the values will be additional indices, and as you can see there are 10 of them. So now we need a method to get data lump. Here we will use the read function from the WAD reader class. By getting information about the lump from the directory, then dividing the size of the lump by the number of bytes of the lump instance, we find their number. By iterating over this number and calculating the appropriate offset, we read all these instances using the specified reader function and put them in a list. At the same time, we take into account the fact that some lumps have their own header, which we will skip. And now we are all set to receive lump data, so let's get all the vertices for the current map. Here we take into account the additional index in the fact that one vertex is equal to 4 bytes. And if we print the values of the obtained vertices and compare them with the coordinates of the vertices from the SLADE editor, then as we see the obtained values coincide, and thus we have received the correct mechanism for obtaining data from the WAD file. And the most interesting thing is not to look at the numbers, but let's render this map in 2D mode. To do this, let's create a settings file. Here we set the original Doom resolution, but this is a rather low resolution and therefore we find the value of the scaling factor, and from which we calculate the final resolution, and also calculate the center of the screen. Now let's import the settings, Pygame and sys modules. In the constructor, we will create a rendering surface of a given resolution, a clock object, running and delta time variables. In the update method, we will receive the delta time value, update the screen and display the current frame rate in the window title. In the draw method, we will simply paint the screen black. And in the check events method, we check the events for the closing of the application, in which case we set the running variable to a false value. The run method will contain the main loop. Here we will call all these methods in turn, and upon completion of the loop, we will exit the application correctly. If we call the run method of the application instance and run the program, we will see a black window of the set resolution, and thus everything is ready to render the WAD file data. So, let's create a map renderer file, and here, after importing settings and Pygame, we will create a class of the same name that has access to our engine's instance. Then you need to import this class in the main file, and create an instance of it in the onInit method. Now we will get access to an instance of the WAD data class and, accordingly, to the list of our vertices. And let's write a method in which we iterate over the list of vertices and render them as a circle, and in turn we will call this method from a separate draw method. And let's call this method from the general draw method, and run the program. And as we can see, nothing is displayed for us, because if you look at the coordinates of the vertices, it becomes clear that none of them fell within our screen, so let's remap the coordinates of all the vertices so that they can be displayed. So, first of all, let's determine the maximum boundaries of the map. For this we sort the x and y coordinates of the vertices and select the minimum and maximum values. Now, with these values, we can write remap methods for vertex coordinates within our screen, with a little padding around the edges. And at the same time, we take into account that for the y coordinate, the y-axis in Pygame goes from top to bottom. And let's apply the remap methods to our vertex coordinates, and look at the result. And finally, we got the display of the map in the form of vertices. This is much better than looking at the coordinates in text form, but of course we would like the vertices to be connected by the appropriate lines, and let's do that. And in Doom, the line that connects two vertices is called line_def. It also serves other purposes, we'll talk about this later. And as you can see, each line_def has 7 attributes of 2 bytes each in the form of 16-bit unsigned integers. As things get more complicated, let's create a file called datatypes. Here we will define a class for line_def. I will use the slots magic method for faster access to attributes and efficient use of RAM. And unlike the Doom wiki, I changed the names of the attributes a little in my own way. So, having imported the datatypes file, we need to write a method for reading data for one line_def from the specified offset. Here we create an instance of our line_def class and read the appropriate data for each attribute, given its C data type. It is also important to correctly increase the offset when reading the next attribute. And in the WAD data class, we will get the data of all line_defs in the same way as with the vertices. And in order to check for the correctness of the received data, I propose to write a convenient method for printing attributes for the case when slots are used for the class. And let's apply this method to print line_def data and look at the result. If we compare the data from the SLADE editor, then we can say that they are all the same, except for the last column. This is affected by the signed or unsigned type of the 16-bit number read. We will process this later. I just went along the path like most Doom source ports. So let's get back to the map renderer class, and here we will get access to line_defs, iterating over which we will get 2 points, on which we will build our line. It remains for us to call this method and run the program. And as we can see, we were finally able to render the first legendary level of Doom, but only in 2D mode. I do not know how easy or difficult it seemed to you. Leave a comment about this. But there are still many interesting and different things to be done ahead.